Hello, Luke. Welcome to Lesson 79. So today we're going to be talking about consecutive odd and consecutive even integers, a spin-off of a previous lesson. And then we're also going to be talking about fraction and decimal word problems, which is also a continuation of something we've already learned. So we're just kind of continuing our journey today. So consecutive odd and consecutive even integers. Let's talk about those. The key point to recognize here is this is very similar to problems that we've seen of old. Just recently, we learned how to solve particular word problems that kind of had this form. Find three consecutive integers such that, and then they might give you, that the first one is twice the second, or the second is twice the third, or what have you. They kind of finished this problem out in different ways. But the important thing that we want to recognize today is the three consecutive integer part. Okay? So what does that mean? Well, that means no matter where we go to the number line, pick your favorite integer on this number line. It really doesn't matter which one. Let's just say you choose -3. Okay? Actually, we'll just circle -3. If that's my first integer, how do I find my next consecutive integer? All right, so if this is, we're going to call it n, as we've done in our other problems. This is our number. And if we're trying to find the next consecutive number, we take this number and we simply add 1 to it, right? -3 plus 1 is going to give us the next consecutive integer. So if n is our first integer, then n plus 1 is going to be our second integer. And then if we're trying to find the third, all we need to recognize is that we need to start with this n again, and this time add 2 to it, and that'll place us right at our third integer. So this is plus 2. So we have our n plus 2 as our third integer. All right, and that's how we solve these problems. Remember, the benefit here is that we now have all three integers, but they're in one variable. All right, which makes it a lot easier to solve. All right, so today, as an extension to that, we're going to talk about odd integers, consecutive odd integers. So first off, we have to remind ourselves what the word odd means and what the odd numbers are. So recall, odd numbers are numbers such as 1, 3, 5. In fact, anything that 2 cannot go into evenly is an odd number, right? So if we were to continue this, 7 would be the next one, 9, 11, 13. We could just keep going on and on and on. All right. Now, if I just choose one of these odd integers, and maybe what we'll do is we'll just circle these on our graph here. We have a -7. We have a -5, -3, -1, 1, 3, 5, 7, and of course it goes on forever. But those would be our odd integers, right? So if I just choose one of those odd integers, you pick which one you'd like to choose. I'll choose the -5, for example. So if I choose this -5 as my first integer, let's call it n, how do I get from this first integer to the next consecutive integer? Remember, consecutive means the one that comes right after. So what's the next consecutive odd integer? Well, it's going to be this one right here, right? We kind of skip the 4 and go to the -3 because that's the next odd integer. All right, so how can I get to that next odd integer if I start with this first one, the n? Well, I would have to add 2 to the n, right? I'd have to take the n, which is the -5, plus a 2 to get me to the -3 because I have to go over two numbers, right? So we have n as our first odd integer. We have n plus 2 as our second odd integer. What do you suppose our third odd integer is going to be? What do you think? If you said -1, you'd be right because that is the next integer down the number line here, the next odd integer down the number line. So that's going to be our next odd integer. But how did I get to that if I start from an n? Well, here I would have to add 4 to it, right? I'd have to add 4 to the n to get me to that next odd integer. So you could say the third integer here is n plus 4. Okay? It's very similar to our consecutive integer here except for now, instead of going immediately to the next one, we have to skip one. So we add twice as much. We add a 2 instead of a 1, and we add a 4 instead of a 2. All right? So hopefully that kind of makes sense. So if they ever ask you to find 3 consecutive odd integers, this is how you do it. All right? Now, let's look at find 3 consecutive even integers. Well, once again, let's just find our even integers on the number line. So 8 is an even number. 6 is, 4 is, 2. 0 is going to be considered one here. 2, 4, 6, and 8. Okay, so there are our even integers. And again, just choose your favorite integer. Maybe this time we'll start with, a 2. Okay, and if this is our n, this is our starting point, that's our first integer. What's the second consecutive even integer going to be? Well, if we started with the 2, the next one would have to be this 4. That's the next one down the road. So how do I get to that 4? Well, if n is 2, I'd have to take the 2 plus another 2 to get me to the 4. So I'd have to take n plus 2 to get me to the 4, right? From there, I'd want to get to the next integer to find my third consecutive even integer. And to find that one, I'm going to have to add another 2 to it. So I'm going to have to add another 4, a 2 plus 2. I had to add a 2 to the n plus 2, making it n plus 4. All right? So that is how you would find your consecutive even integer. Notice it's the same setup as the odd integers. Why? Because there's the same distance between odd integers as there is between even integers. They both just skip the number. They just complement each other. Okay? So there you have it. That is how you would solve these story problems when they say even integers. All right. All right, so now that we kind of understand the setup, let's try a problem and see how you do. So, the first one, find 3 consecutive even integers such that the sum of the first and second equals the sum of the third and negative 10. All right, sounds complex, but I think once we unpack this, we'll find it's not so bad. All right, so first off, we're looking for 3 consecutive even integers. So right away, we need to start thinking about the setup. So we're going to have an n for our first integer, and then it's a consecutive even integer. So the next one's going to be n plus 2, right? And then the third one's going to be n plus 4. All right, so there, those are our 3 integers. We just don't know what n is yet. All right, so such that the sum, all right, well, what's the sum? The sum indicates addition. So something is being added together. The sum of the first and second. So the first and second are being added together. This is the first, this is the second. So we know they're being added together. So we have an n plus 2, right? Okay, so that sum, this sum right here, this sum, equals the sum, another addition problem, of the third and negative 10. So what's the third number? It's n plus 4, and we're adding that to a negative 10. That's the sum of that, right? Okay, so now we have it all laid out. Now we just need to solve it. Since this sum here is all by itself, we can drop the parentheses. I didn't need to put those, but it is a good idea to put them sometimes, because sometimes they'll say something like the sum is being multiplied by a 4 or something, in which case you'd have to multiply this whole set of parentheses by a 4, right? Not just one of the terms in there. But in this case, they didn't do that. It's just the sum of an n plus an n plus 2. So we can drop those parentheses and we can combine like terms here. So n plus n is 2n plus 2 equals, over here, again, we can drop these parentheses. It's all by itself. We're going to have a plus minus, which means a minus. So we're going to end up with n plus 4 minus 10, which is a minus 6, right? All right, now we can get our n's onto one side. So we'll subtract an n from that side and subtract it from this side. Our next step is going to be get the n's by themselves. So I'm also going to move this 2 over to the other side. I'm just combining a step here. which is fine. We can do that. These will eliminate. This 2n minus n is going to give us an n. That's awesome. Over here, these n's will eliminate, and we have negative 6 and a negative 2 is a negative 8. And lo and behold, there we have it. Exactly what we were looking for. N is equal to a negative 8. So if n is equal to a negative 8, well, that means the next number is going to be a negative 8. A negative 8 plus 2. And the next number is going to be a negative 8 plus 4. So just kind of combining some terms here, we have negative 8, negative 6, negative 4. So there you have it. There are our 3 consecutive even integers such that the sum of the first and second, which would be negative 8 plus negative 6, that's a negative 14, and the sum of the third, negative 4, and a negative 10. A negative 4 and negative 10 would also be a negative 14. So therefore, great. That is the correct solution. All right, let's try another one here. Why don't you pause the video, try this one yourself, and then we'll do it together. All right, so once again, we're looking at 3 consecutive odd, this time, integers. That's not really going to change our setup. We're still going to have an n for our first number. Because it's odd, we need to skip one and go to the next one. So it's going to be n plus 2 will be our second number, and n plus 4 is going to be our third number. All right? So, such that the sum, all right, so we're talking addition again. So we'll put our addition sign. What's being added? The sum of the first and third. The first and third are being added. The first is an n. The third is an n plus 4. So n plus 4. That's our sum. Again, I'll put this in parentheses just in case there's multiplication. Is, in this case there isn't any multiplication, we're already to the equals 7 greater than the second, decrease, that's a typo, should be an A in there, decreased by 18. So we have 7 greater than, all right, so it's something has 7 being added to it. So what's having 7 being added to it? Well, it's greater than the second, but it's more than that. It's greater than the second decreased by 18, all right? So it's 7 greater than the second decreased by 18. So we have the second, which is this n plus 2. That n plus 2 is being decreased by 18. So we need to take 18 away from that. But then this whole thing right here, it's 7 greater than that. So we need to add 7 to that. All right. So do you see how that worked out? It's 7 greater than the second decreased by 18. This is the second decreased by 18. And then it's 7 more than that. So we're adding 7. Okay? All right, so at this point, we look through and start working it out. This set of parentheses is all by itself, so we can drop them. We can combine like terms, and we get a 2n plus 4. Over here, this set of parentheses, there isn't any multiplication on the outside. It's just addition, so we can drop them. That's fine. And if we do that, we can combine some like terms. We have a plus 2 and a negative 18. That's going to be a negative 16. And then a negative 16 plus a 7 is going to be what? A negative 9? Negative 9. All right. Now we can move our n's over onto one side. So we'll subtract n from both sides. I'm going to move this 4 over to the other side. So I'm going to subtract 4 from both sides. And we end up with an n is equal to negative 13, which is great. That's what we're looking for. So now let's figure out the rest of the numbers. So the rest of the numbers are going to be, well, 13 is our first one, negative 13. And then we have negative 13 plus 2 is my second, and negative 13 plus 4 is my third. So I have a negative 13, a negative 11, and a negative 9. Whoops, negative 9. There it is. That is my solution. All right, let's try one more just to make sure that you've got this. Pause the video and then try this yourself. All right, so this one says find four consecutive odd integers. All right, so right away I can start thinking what my variables are going to be. So I'm going to have an n for my first one. Because this is consecutive odd, I'm going to have to do, the n plus 2. Skip 1, go to the next one. My third number is going to be n plus 4. And now I need a fourth number. So the fourth number is going to be n plus 6, right? Because I keep going up 2 for every new integer. All right, so there are my four numbers. Now what do they want to, how do they have these arranged? So such that the sum, again, we're talking addition. It seems to happen a lot. So we have an addition problem. The sum of the first and fourth. So here's the first, here's the fourth. We're adding those together, n plus 6, and we'll put that in parentheses again, just as a caution. And then that's equals. Okay, so the is equals 25 greater. Well, if it's greater than what? We have to look at that. It's greater than the opposite of the third. So it's greater than this part. So what is the opposite of the third? Well, the third number is this, is this one. So the opposite of that third number is going to be its negative. So it's going to be a negative. Now be careful here. It's negative, and then I'm going to put in parentheses the third number, n plus 4. Okay, notice I put this in parentheses. It's because this is the full third number, right in the parentheses here. That's one kind of, it's one set, one group right there. That's the number. And we're finding the opposite of that. So we're taking the negative of that whole number. It's not just a negative n. It's not just a negative 4. It's a negative n plus 4. Okay, it's a group. Okay, now that's the opposite of the third, but we need 25 greater than that. So we need to add 25 to this opposite of the third. Okay? All right, now let's go ahead and start simplifying. This again, we don't need the parentheses, so we end up with 2n plus 6 equals. And then over here, we do have to distribute this negative through, don't we? Right? So it's negative n, negative 4, and then we have this plus 25 tacked on at the end. All right, let's move the n over to the other side. So we'll add n here, and I'm just going to move this negative 6 over to the other side too. And we end up with, the 6's will cross out, 2n plus 3n, 1n is 3n, equals, the n's cross out. Negative 4, negative 6 is a negative 10. We still have the plus 25. Negative 10 plus 25, that's going to be equal to 15. So we end up with 3n is equal to 15. We can divide both sides by 3, and n is equal to 5. Okay, so if that's n, what are the other three numbers? So we have 5 is our first one. That's our n. Now for the second one, we have 5 plus 2, and then we have 5 plus 4, and then we have 5 plus 6. So we end up with 5, 7, 9, and 11. Those would be the 4 consecutive integers, odd integers, that we're after. All right? Very good. So hopefully that is pretty clear to you. I think now we'll move on to the next part of our lesson today, which is the fraction and decimal word problems. Okay, so these problems, I guess we're going to treat them in a very similar way that we did percent problems. So you remember our good old friend, the bubble diagram. We'll be using the same one for these fraction and decimal word problems. Hopefully you've done the percentage ones enough where this should be almost second nature to you. But let's go ahead and work it out. The only difference here is we'll be having one of two options. We might have, the first bubble and then the second bubble. And the second bubble might be a divided bubble. This first bubble, instead of it being, the 100%, remember we'd sometimes write that underneath. Because we're not dealing with percentages now, we're dealing with fractions and we're dealing with decimals. This percentage, this 100% doesn't make sense. We're not dealing with percentages. And because we're dealing with fractions and decimals are just parts of a whole, right? That's what a fraction is. It's a part of a whole. That's what a decimal is. So this one, we can just get rid of the 100%. We're going to actually call this one just 1, all right? The first bubble just represents 1, okay? Think of it as a fraction and a decimal. They're all taking a pie or a pizza and they're cutting it up into different sizes. And then, a fraction is going to take a certain number of those pieces, right? So this first bubble represents the whole pizza or the whole pie, whichever you prefer. It's the whole thing. Okay, and then the second bubble kind of represents, the fraction of how much we took and the fraction of how much is left. Okay, so again, this first bubble, we're going to think of it as a 1, meaning a whole. Okay, 1 whole. Okay, all right, so kind of keep that in the back of your mind. So let's just read the story problem and see what it looks like, and then we'll try to attack it using our bubbles. So Lopez used a 5 iron. But the ball covered only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? Okay, so we need to break this up into our bubble again. So we've got our first bubble, and we're just going to call this the number 1 bubble, the full bubble, the whole bubble. Okay, and then we've got our second bubble. We need to decide if we're going to do this format with the the divided bubble, or are we going to do this format? Remember this one, the double bubble? All right. So we need to really first look at what's the starting point here. What's the original amount? All right. So Lopez used a 5 iron, but the ball covered only 4/5 of the required distance. So 4/5 obviously is not what's in this whole bubble because it's not the whole pie. It's only 4/5 of it. Okay. So that's not it. If she hit the ball 112 yards, well, she hit the ball 112 yards. That doesn't tell us that's the total length of what she wanted to go. What was the required distance? So the required distance would be all of the distance, the whole distance that we're looking at. So whenever we find out which number represents the whole amount, that's the number that's going into this first bubble. All right. Now, they didn't tell us that. That's what we need to find out. So we'll just call this D for distance. Okay, the whole distance. What was the whole distance that she wanted to go? All right. Now, is this going to be a double bubble? So did we start with a distance and then increase that distance? Well, no, right? We started with a distance. She tried to hit the ball the full distance, but she didn't make it. She only made it 4/5 of the way. So she didn't even make it the whole distance. So we're certainly not growing that distance. So we're going to use the single bubble that's then divided up into 2 sections. Okay? All right. So once again, we need to figure out what goes into this double bubble now, just like the old problems. So what do you think? What number should go into this double bubble part here? See if you can figure it out. Well, it's a part of the distance. And actually, it's a good idea on these ones to write the of over here. I know we did that on some of the percentage problems, but it is a good idea, actually. I think it'll help you if you do remember to write that of right there. And remember, of always means what? Multiply in algebra. Okay? All right, so of D. Now, let's think about it now. What would go over here? So it's going to be a fractional part of the distance. Well, 4/5 is a fractional part of the distance, of the required distance. So 4/5 is certainly going to go in here. 4/5 is going to go in here. All right? And then we have, what does that equal to? That's the fraction. How many yards is 4/5 equal to? Well, they tell us, actually. It's 112. And actually, I'm going to back up a second here. We're going to write that 4/5 in, but I think it might be better to maybe, and you can even put these equal signs in before you even figure out any of your numbers. But I would say aim at putting the fractional part on the right side. I think it'll just make a little bit more sense to you when you try to find your equations. So this 4/5 is correct. We do want to put it in here, but we're going to put it on the right side. All right, so put your equals, find the fraction that's going to be a part of this original distance, and put it on the right side. All right, so what does 4/5 equal? Did they tell you? Well, that's the amount of distance that she hit the ball. That's the ball covered 4/5 of the distance. Well, how many yards was that? Did they tell us? Well, yes, they do. She hit the ball 112 yards. So that means that 4/5 is equal to 112 yards. Okay. All right, now we have to fill in the lower part of the bubble. So kind of like what we used to do with percentages, if in the top percentage or top bubble there was, 25%, well, then in the bottom bubble we said, well, what's 100 minus 25? That means there has to be 75% in the lower bubble, right? We can figure that out because these two have to add up to 100, right? Same thing kind of applies here. This 4/5 and whatever's in this lower part have to add up to the whole amount. So what would you need to add to 4/5 to get it to 5/5? Because 5/5 would be equal to the whole amount. Well, if you have 4/5, what's left over? You have 1/5 left over, right? So 1/5 is going to go down here. Notice again, these two numbers are going to add up to a 1, which is the whole amount. Okay. All right. So we have a couple of unknowns now. We have the d, which is an unknown. We also have, this, maybe I'll call it small d, the small distance here, which is the distance that she still has to go to get the ball to the spot she wanted to get it to. She drove it 112, but she needs to drive it further. All right. Okay. So we now need to start thinking of equations. And this is where I said that of kind of comes in handy, because what you want to do is go to your bubble, pick the one that you know the most of in this case, because we're really trying to find this capital D, because that's what they're asking for. What was the required distance? Well, this is the required distance. This is the full distance. So we're trying to solve for that. So that's one variable right there. So we have to combine one of these parts over here with this to make an equation that we can solve. We don't want to use the lower one, because if we use the lower one, now we have a capital D and a lowercase d to solve for. Two variables. That's not helpful. So we choose the upper one because that doesn't have any variables in it. All right. What you want to do is read this equation from left to right, and then just remember that the equation continues by wrapping around and starting back over here. All right. So this would read 112 is equal to 4/5 of the total distance, d. All right, make sure you can see how I did that. 112 is 4/5, and then I wrap all the way around to the beginning, and I just rewrote this, of d. And that should make sense when you think about it too. 112 is 4/5 of something. It's 4/5 of something, right? It's 4/5 of what? It's 4/5 of the total distance. Okay, once you have it in this form, now we can solve, because we know that 112 equals 4/5, and this of means multiply of d, and this is an equation in one variable. So how would we solve? Well, we can multiply both sides by a 5/4, right? If we do that, then these will cross cancel out, and we're left with just a d. Now 5/4 times this 12, let's see here. 4 can go into 112, I believe. 4 can go into 11 twice. And 4 can go into 32 8 times. So this would be a once, and this would be a 28. So we end up with 5 times 28. Okay. And 28 times 5 is what? 140. So we end up with 140 equals the d. That was the total distance she wanted to drive the ball, 140. All right, so we could replace this d with 140. Now we could look at this lowercase d if we wanted to complete the diagram and say if the total distance was 140, lowercase d is something, 112 plus that lowercase d has to be 140. So we just need to take 140 minus the 112 to find out what's left over. That's how far she wanted to drive it. This is how far she drove it. How much further does she have to go, right? So we subtract, and we end up with 28. So this lowercase d could be written as a 28. Okay? All right, very good. So I went into that maybe into more detail than I needed to, but hopefully you understand how I did that. Let's try another one, and this time try to do it on your own first, and then we'll do it together. All right, so McBee guessed that the total was 30.24. But this was 7.2 times the total. What was the total? Okay, so we have our first bubble. Well, let's just, I guess we'll go into the black here. Our first bubble, and remember we're going to call this kind of the one bubble, the whole bubble. And then we're going to have our second bubble. We're not sure yet whether it's going to be a divided one or a double bubble. So let's look at the problem. What would be the whole amount? McB guessed that the total, well, the total would probably be the whole amount, right? So she guessed the total was 30.24. Now watch out. Was the total 30.24? No. This was 7.2 times the total. What was the total? So this one, remember, kind of represents the total, the full amount. That one's going to be a T in this case. I'm just calling it a T for total. And I'm going to write that little of before it too. All right, so there's my total. It's unknown. That's what we need to figure out. So did the total grow or did it stay the same? Well, McB guessed the total was 30.24. And this 30.24 was 7.2 times the total. In other words, it was way too big, right? 30.24 was over 7 times too big. All right, but that's her guess. So what did she do? She actually did enlarge the total, right, in her guess. So her guess is going to be a double bubble because she is enlarging the total by 7.2 times. Okay, so what's the fraction? In this case, it's a decimal. What's the decimal that we're interested in? You have to be a little bit careful on this one because they're both decimals. She guessed a decimal, all right? But the decimal that we're interested in is actually the 7.2, the 7.2 times the total, okay? So I could write in my bubble here 30.24. That's just a number. That didn't have to be a decimal. It's just 30.24. It happens to be a decimal. 30.24 is equal to this 7.2 times the total. All right? Or you could say 7.2 of the total if you wanted to. All right? So 30.24 is equal to 7.2 times the total. All right. So now let's write the equation out for this. So 30.24 is equal to 7.2. I just rewrote this double bubble. And then remember, I trace it back to the beginning. 7.2 of the total. Of means multiply. So it's times the total. All right. Or I could even write that without the parentheses and just write it as times t. Okay. So now we need to do a little bit of computation here. We're going to solve for t, so we're going to divide both sides by a 7.2, right? And when we do that, we're going to end up with, and I'm going to cheat and pull out my calculator here, divided by 7.2, 4.2. 4.2 is equal to the total, okay? So, there you have it. It's as simple as that. This total becomes 4.2. That was the total. She guessed 30.24. So she was way off the mark. All right. Or he, whichever one it was. All right. 30.24 is nowhere near 4.2. In fact, it's 7.2 times too big. But they wanted to know what the total was. The total was 4.2. Okay? Very good. All right. Let's try one last one, and hopefully that will solidify it enough for you so that you can do these on your own. Go ahead and pause the video, try it by yourself, and then we'll do it together. All right. So we have our bubble. This is our one or our whole or total, whatever you want to think of there. 3/4 of the tickets had been sold. Okay? And there were 420 tickets left. How many tickets were printed? So this first bubble here, this total, that's going to represent the total number of tickets, which they didn't tell us how many there were. They just told us that 3/4 of them were sold and there were 420 tickets left, but they didn't tell us how many there were. So that's really their question. How many tickets were printed? So that'll be our T. That's our unknown. And I might even write the of here, of T. Okay. Now our second one, we have to decide, are the number of tickets growing in this problem, or are they being divided up into two different groups? And if we look at it, 3/4 of the tickets had been sold and there were 420 tickets left. So 3/4 is not more than the total. So we're not growing it there. And then in the second part, they're just telling us how many are left. They're not expanding the number. So it's pretty clear here that it actually is just a divided bubble. Okay. And then they tell us that 3/4, actually, let's put our equals in here. So we put our equals in. All right, so 3/4 of the tickets had been sold. So right away, we should see that fraction and go, all right, 3/4, that's going to be one of these. And remember, write it on the right side. It's a little more helpful, I think. And then if there's 3/4 here, what's going to be down here? What fraction is going to be down here if this is 3/4? Think about it. Be 1/4, right? Because these two have to add up to 1. So 3/4 and 1/4 would be 4/4, which would be 1. All right, so there we go. We have our bubble divided up now. Now what did they tell us? Now remember, this 3/4, maybe just make things clear. I'm going to just add a little note here. This 3/4 represents the tickets that were sold. Okay, which would mean this represents the unsold. Right? 3/4 were sold, 1/4 was unsold. Now, what number do they give us here? They say there were 420 tickets left. Key word right here, left. Okay, so that means they were not sold. If they're still left, then they weren't sold, right? So this number has to go in the unsold part of our bubble here. So that's going to go over here, 420. 420 is going to be equal to 1/4 of the total. Okay, so this upper one, maybe we'll call it S for the sold ones. That one's an unknown. We don't know how many they actually sold. We just know that they sold 3/4 of the total. All right, so now we're ready to find an equation here. And they want to know how many tickets were printed. So we're looking for this. So that's already a variable. So we need to use something over here that doesn't have a variable in it. And it's going to be the lower part, right? So we're going to use the 420 is equal to 1/4. And then we have to, again, wrap this around of, meaning multiply, the total, which is a T. All right. Now we can just divide these things, or multiply these things out. We'll multiply both sides by a 4. Okay. And that's going to give us a T on our right side. 420 times 4 is 1,680, if I did that math right. So the total then is 1,680. That is the total number of tickets. Now let's just make sure it passes the smell test here. If the total number of tickets were 1,680 and, you know, 1/4 of them were unsold, 3/4 of them were sold, 1/4 of them we said was 420. Does that look right? 420, does that look like about 1/4 of 1680? Yeah, that looks right. Okay. If I wanted to, I could figure out what the S is too. If 420 were unsold, well then I could take that away from the total number of tickets. And we get 1,260. So that means the sold amount was 1,260. Which would have been 3/4 of the total. That all looks right. Nothing looks weird there. So we know we did it all right. And of course the answer here, they wanted to know how many were printed. So this total is the answer, the solution. All right? Very good. So hopefully that all made sense. Again, this is nothing too new. It's just kind of an expansion of what we've already learned with percents. We're just kind of using the same method for decimals and fractions. All right. Well, we will stop here and good luck with the seat work, and I will see you next time.